Okay, this is going to be the first chapter of the Advanced Math Trig unit. You've gotten a sample test. I'm going to write in a lot of the numbers here, so you have them on your sample test, so we'll go with that. All right, so on number 1, you have 8, 15, and x. Obviously, this is the 90-degree angle. All right, so if we're solving for x, in this case, we have enough to do Pythagorean Theorem, okay? So we're going to have 8 squared plus 15 squared equals x squared, okay? That's 64 and 225, which is 289, okay? And so what I'm going to do is I'm going to take the square root of 289, okay? So I take the menu run, all right? I'm going to take the square root of 289, and I get 17, okay? So my answer there is 17. 17 is x, okay? On number 2, I've got x, which is 20, 24. All right, I can do Pythagorean Theorem again because I got 2 sides and I need to find the third. So x squared plus 20 squared equals 24 squared. Okay, so that's x squared plus 400 equals 24 squared, which is 576. I'm going to subtract 400, which is going to be 176. And take the square root of that, okay? Now, when I take the square root of 176, it's going to be a nasty decimal. So, what I'm going to do that is I'm going to break down 176. So that's 2 and 88, I believe. 2 and 44, 2 and 22, 2 and 11. Once again, can't use these branch terms. Here's a pair, here's a pair. So what I would have is 2 times 2 with the square root of 11 on the inside, so that's 4 square root of 11. That's going to be my answer, okay? So it's going to be 4 square root of 11. Let me erase this right here, okay? All right, so we have enough room for the next problem. Okay, now, on this one, you have x, you have 50, and you have 20 degrees. Now, what we have to do is make sure your calculator's in degree mode. So I'm going Shift, Menu, I'm going down to Angle, and make sure it says degree, so F1. Now I'm good, okay? So what I want to do is I want to label this hypotenuse, okay? Since this is my angle, that's going to be my opposite and adjacent. So the 2 letters I have information for are opposite and hypotenuse, so that's going to be sine of 20 degrees, so you put your angle in first, opposite is x, hypotenuse is 50. To solve these problems, I move the 50 up there. So the way I type that into the calculator is 50 times the sine of 20 degrees, and you get an answer of 17.10. Okay? Moving on to number 4, I've got 36, I've got x, and I've got 40 degrees. Once again, labeling off of this is the hypotenuse. Diagonal over here is opposite, this is the adjacent. So the 2 letters I have information for are opposite and adjacent, which is tangent. So tangent of 40 degrees equals 36 over x. And what I'm going to do is when the x is in the denominator, I literally switch places there. So what ends up happening is I've got 36 divided by the tan of 40. And I got 42.9 degrees, or 42.9. 90. Okay, and there's my answer for that. Okay, moving on. Number 5, okay. I've got a 32 right here, 90 degrees, 53, and an x, okay? Now, this is the hypotenuse. Since I'm going off this angle, this is considered the opposite, and this is considered the adjacent. So the 2 letters I have is opposite and hypotenuse, so I got sine. So sine of 53 equals 32 over x, okay? All right, keep in mind, SOHCAHTOA, that is the ratio, okay? These are the ratios right here. All right, so that helps you set it up, okay? All right, so that's how I got opposite over hypotenuse, all right? All right, so now what I'm going to do is this and this switch spots, okay? So what I'm going to have is I'm going to have the division sign. 32 divided by the sine of 53 is 40.06. Okay, number 6. 24 degrees, and 15, and x. So this is the hypotenuse. Going across here is the opposite. This is the adjacent. Okay? So the two things I have information are O and A, so that's tangent. So tangent of 24 equals the opposite 15 over the adjacent x. Once again, this and this are going to switch spots. Okay? So I got 15 divided by the tan of 24. I get 33.69. Okay? Number 7. Number 7 has a 32 here. Okay? A 75 here. And an x here. Okay? This is the hypotenuse once again. This diagonal over here is the opposite. This is the adjacent. Okay? All right? So I'm given the letters for opposite and adjacent, so I got tan again. So tan of 75 equals, okay, the opposite over the adjacent. Once again, I'm switching spots here, okay? So I got 32 divided by the tan of 75. I got an answer of 8.57. Okay? All right, let me go ahead and erase this, okay? So I got room to do that last problem. Okay, on this one I've got x degrees. We've got 60 and I've got 28. Okay, obviously this is the hypotenuse. Diagonal here is opposite. This is the adjacent. O and H is what I have, so side. Now in this case I don't know my angle, so that's x degrees equals 28 over 60. Now, in order to calculate this one, I'm going to do a little -1d, okay? So if you notice above sine, there's a -1. So I said shift that, put parentheses around your fraction, just like we always do. And that gives you 27.81 degrees, okay? Moving on. Number 9 through 12, okay? It says find all the angles, find all the sides, okay? Now, so what I have is A, B, and C, 18 and 37, okay? Now, what you want to do here, all right, is I got angle A, angle B, angle C, side little a, little b, little c. I like to fill in as much as I can. For instance, B is 90, okay, C is 37, okay? In a triangle, the difference here, 180 minus 90 minus 37, okay, the triangle has up to 180, so that last one's got to be 53. So I'm going to put that in green. That's what I found, 53 degrees. Now, one thing you have to understand about the sides. To figure out what letter the side is, if this is big B, the opposite side, if I drew a diagonal, would be little b, okay? So little b is going to be 18. All right, I'm given that. All right, now, what I want to do, and I have the freedom to do what I want, but let's say I want to find little a. Well, what's little a? Little a is this diagonal here. So this is little a. This is what I'm going to find. I'm going to label off of the angle that I have. Okay? Even though you just found 53, use the angle you have. It makes it a lot easier. Okay, we're still good. All right, so what I'm going to have is this is going to be the hypotenuse. If I drew a diagonal line to there, that would be the opposite. This would be the adjacent. And so what I have here is I've got adjacent and hypotenuse. So I'm going to do the cosine of 37. I don't know the adjacent, or little a is what I'm going to use. But I know the hypotenuse of 18. So the way you solve this is the 18 moves out in front. So I got 18 cosine of 37. And so that gives me 14.37. So little a is 14.37. Now, what I like to do here to help me is I'm going to go ahead and cross this out as if this is blank. Okay? I have to find little c. Well, that's diagonal of this, so that's right here. Okay? So now this is the variable I'm going to find. So this one is blank now. So I have opposite and hypotenuse, which is sine. I'm using the same angle of 37. All right, c and 18. 18 is going to move right up in front of there. So I got 18 sine of 37. So c is 10.83. Okay? And that's how you do that problem. I think to create less confusion, go ahead and cross out whatever letter you're done with. But do one letter at a time. Okay? I'm going to erase this right here so I have room to work on this problem for this, okay? All right. All right. So this is labeled D, E, and F, okay? This is 60 degrees, and this is 24. So let's go ahead and write out these things. I have angle D, angle E, angle F, okay? I already know angle E, which is 90, and I know angle F, which is 60, okay? So to figure out the missing angle there, 180 minus 90 minus 60, 30, okay? So I got 30 degrees, okay? So then I want to have little side D, little side E, little side F, okay? Now, which side do I know already? Well, 24 is opposite of little d, so that's going to be 24 right there, okay? Now, to find the other ones, okay, all right, little e is right here, it's located right there, okay, because that's opposite of that, all right? So what I want to do is label this. This is the hypotenuse, okay? I'm going off of 60 degrees. So this is the opposite, and this is the adjacent, okay? So for me here, all right, the only thing I have is I have the hypotenuse and the adjacent, okay? So that makes its cosine. So cosine is 60 degrees, all right? The adjacent was 24, the opposite was e. So to solve these, I'm switching spots with both of those. So what that's going to be is it's going to be a cosine of 24 divided by the cosine of 60 degrees. I got 48, okay? So little e is going to be 48, okay? So now what I'm going to do, so I'm not confused, is I'm going to cross off little e, and now I got to find f. So f is located over here, okay? Once again, I'm going off the same angle. If you keep everything the same, it makes it a lot easier, okay? So now I've got opposite and adjacent, okay? So opposite and adjacent is tan. So tan of 60 degrees, okay? All right, I've got the opposite, which is little f, all right, over the adjacent, which is 24. To solve this one, I move that 24 up, okay? So I'm going to have 24 tan of 60, whoops, and I get 41.56. So little f is 41.56. Like I said, keep that same angle. Don't write everything in there. It makes it a lot easier, okay? Moving on to number 11, okay? Moving on to number 11. Number 11, I was given 7 and 25, A, B, and C. Okay, so angle A, angle B, angle C, little a, little b, little c. Okay, now, for these, all right, I do know some things already. All right, I know angle B, which is 90, okay? I know, if you look at this diagonal right here would make that little c. This diagonal here would make that b, okay? All right, now I got to find A, C, and A there, all right? Now, you can handle this a number of ways. Let's say I wanted to find this third side. Well, I can do Pythagorean Theorem for that, okay? So this little is side little a, okay? That side is little a. All right, so if I want to find that, that's going to be little a squared plus 7 squared equals 25 squared. Okay? And the reason I don't have to use trig for that is I have 2 of the sides already. So 25 squared, all right, and 7 squared. And what I'm going to end up doing is subtracting that. I just want to get the numbers down. Okay, so I've got 625 and 49. Subtract 49 is 576. Square root of 576. Let's see if that's a nice decimal. Square root of 576. And it is. It's 24. Okay? So a is 24. Little a is 24. So boom there. And then I'm going to cross that out. I don't need that anymore. All right? Now, what I want to find is I want to find one of these angles. Let's say I want to find angle A. Okay? So I'm going to put a little variable there for me so I can figure that out. Now, if I label it off of this angle that I'm trying to find, this is the hypotenuse, this is the opposite, and this is the adjacent. So the two things I have is I've got the adjacent and the hypotenuse, so I'm going to have cosine. So cosine of my angle that I don't know is 7 over 25, and I'm going to do the inverse cosine to help me get that answer. Okay? So I'm doing inverse cosine, 7 divided by 25. Okay, I've got 73.73 degrees. Okay, so I got 73.73. That's angle A. Now, the nice thing is, okay, I can go ahead and just go ahead and subtract 180, the 73.73 I just found, and the 90 away. And that helps me get 16.27, which would be representative of angle C. My screen's flashing, so give me a second here. Okay, 16.27. Okay. All right, on number 12, this is 8, this is 2, D, E, and F. Okay, so once again, angle D, angle E, angle F, little d, little e, little f. Okay, what do I have so far? Well, I've got angle F, which is 90. I've got little d, which is 20. I've got little f, which is 8. Okay, so if I want to find E over here, okay, what I can do is I'm going to do, let's say I want to do little e. I'm going to do e squared plus 2 squared equals 8 squared. Okay, so that's e squared plus 4 equals 64. I would subtract the 4. That's e squared equals 60. Take the square root. Okay, for solving the triangle, I would be more lenient here. I would allow you to just give me a decimal. I don't really care about that. 7.74. I would let you do that for that one. Okay. For ones where it's just solving for x, all right, go ahead and like this one up here, make sure you reduce it properly. Okay. All right. And you'll have to be able to reduce one in a little bit. Okay. So go ahead and do that. All right. So if now I don't want to use little e anymore, so I'm going to cross that out, so it's still blank. All right, let's say I want to find angle D, which is this angle here. That's going to be the hypotenuse. From here, that would be the opposite. This would be the adjacent. So what I have here is I have sine, because I have opposite and the hypotenuse. Okay, so I'm sort of running out of room here, so let me see if I can. All right, so I got sine. The angle I'm trying to find is 2 over 8. So I'm going to do the sine angle finder for 2 over 8. Okay, so sine angle finder for 2 over 8 is 14.47. Okay, 14.47. Okay, so I'm going to do 90 minus 180 minus 14.47 minus 90. So what I got is 75.53. Is that right there? Okay. Moving on to the next page. Okay, these are your word problems. Say a surveyor is standing 75 feet from the base. Okay, so from the base, that's referring to this. We're always going to have right angles with this. The angle of elevation is 32 degrees. Okay, so angle of elevation or depression always goes there. How tall is the tree? How tall would be over here? Think about the height. So when you label this, this is the hypotenuse. This is the opposite. This is the adjacent. So just like our normal trig, I got opposite and adjacent, which is tan. So tan of 32 equals x over 75. To solve that, I move that 75 up. So 75 tan of 32. And I get 46.86. Okay, and that'll be feet, I guess. Okay. It says somebody's riding a sled during the winter on a hill that is 200 feet, okay? So the hill, usually the object, if somebody's on a slide or a sled or a line, that's usually going to refer to this. Angle of depression. Angle of depression, that's still going to be in that corner. Don't get confused. 47 does not mean here, okay? When you look at, okay, angle of depression, and the way this works is they're referring to this kind of parallel line relationship. Okay, so all you really need to know is if they say depression or elevation, that's the angle there. It says how high is the hill at its peak. Okay, so what we're doing is that. Okay, so this is the hypotenuse, this is the opposite, this is the adjacent. So in this case, the variables I have there are sine. So sine of 47 equals x over 200. And what I would do is I move the 200 up there to give me my x. Okay. 200 sine of 47. And that's 146.2. 146.27. Okay? In the up movie, the house needed to clear the building after it lifted off the ground. The distance from the house to the building was 80 feet. Okay? So if I'm drawing my right angle, that's that distance. How far? Distance, all that. Angle of elevation, 71. How tall was the building? Okay? So once again, that's hypotenuse, opposite, adjacent. We have a tangent again. So tangent 71 equals x over 80. I'm going to move that 80 up there. So that's 80 tan of 71. I get 232.33. Okay? We got 3 left here. All right, the teenager is creating a zip line from the house. The zip line goes over a pond of water. The distance from the end of the line to the house is 120. Okay, so that's going to be 120. It's a depression of 25 degrees, so that's going to go here. All right, how long is the zip line? That's going to go there, because that's that part of it. So it's the hypotenuse, the opposite, and the adjacent. In that case, you have adjacent and hypotenuse. Okay, so that's going to be cosine. So cosine of 25 equals 120 over x. This is one where we're going to put that underneath and move that up. Okay, so that's going to be 120 divided by the cosine of 25. All right, 132.40. That's going to be my answer there. Okay, a plane is beginning to descend to Dulles Airport. The plane is approximately 25,000 feet from the beginning of the runway, a horizontal distance. Okay, so it's sort of nice there, 25,000 feet. Okay, the plane is at an altitude of 15,000 feet. So altitude means height. What is the angle of depression? So that's what I want to find. Hypotenuse, opposite, adjacent. Okay, 2 I have there are tangent. So tangent of the angle I'm trying to find, 15,000 over 25,000. Okay, so I'm doing inverse tan there. Okay, or tan negative 1, 15,000. Divided by 25,000. Okay, that's 30.96 degrees. Okay, is my answer there. Okay, a skateboarder is riding his skate on a board on a ramp. The ramp is 20 feet high and 63 feet long. All right, so 20 feet high, 63 feet long. What's the angle of elevation, which would be right there? So once again, height, opposite, adjacent, opposite and hypotenuse is sine. Sine of the angle, 20 over 63. So that's the inverse sine function. Okay? All right, so sine 20 divided by 63. Okay, so 18.5 degrees. Pretty lousy ramp, to be honest. Okay? All right, going on to the last part of the sample test. Okay, there is a mistake on this sample test. This should be 24. All right, that should be 24, so please make that adjustment. So here's the idea, okay? What we can do, we treat this like our x and this is like our y. So to make this easier on yourself, go ahead and put your 24 there and your 7 there. What you need to do is do the Pythagorean Theorem to figure out what your hypotenuse is. Call that h. Okay? So what I got is 7 squared plus 24 squared. Okay? All right, and that's going to be 625. And take the square root of 625. Okay, it's 25. All right, so what I got is 25 there. Now, as you saw, that's negative, so I'm going to go ahead and put that negative right in there. I do that at the end. Wait to the end to do all your negative stuff. Okay, so we know this is the hypotenuse. Okay, for the interest, we're always going to go off of this corner angle. This makes it easier on us. So this is the opposite, and this is the adjacent. Okay, so pretty easy. Sine is opposite over hypotenuse, so negative 7 over 25. Cosine, adjacent, 24 over 25. okay? And tangent, negative 7 over 24, okay? All right, and what you do to get the coinciding ones, all you're doing is flipping them over if they're just fractions. It's pretty easy if that's the case. Okay, easy stuff there, okay? On number 20, okay, 8 squared plus 2 squared equals my hypotenuse squared, okay? Because this is going to be 8, 2, and that's going to be my hypotenuse, okay? So that's going to be 64 plus 4, which is 68, okay? Whoops, I didn't do that right. Hold on. Hypotenuse squared. All right, so that's going to be height squared. 68 equals my hypotenuse squared. So I'm going to take the square root of that, and I'm going to break that down. 2 and 34, 2 and 17. Okay, can't use these anymore. Here's my pair, so that is going to be 2 square root of 17. Everything is positive here. Here's my hypotenuse. Here's my opposite, here's my adjacent. Once again, we're going to go off of this little corner part here, okay? Now, sine is opposite over hypotenuse. So I'm going to have 2 over 2 square root of 17. Now, the way you handle this, whatever's inside that square root, you're going to multiply by the top and the bottom. So what I'm going to have there is I'm going to have 2 square root of 17 over, and I'm going to use my calculator, okay? 2 square root of 17 times the square root of 17. This makes it easier just to multiply by the same thing. I get 34, okay? And what you should do is divide 2 divided by 34. So as a fraction, do fraction and decimal, that's 1 over 17. So that's 1 over 17 square root of 17. That is your sine, okay? Cosine, 8 over 2 square root of 17. Once again, it's going to be the same thing. Now, from a shortcut standpoint, you know this is already going to be 34. So I got 8 over 34 with the square root of 17. Okay? All right, I didn't get much room here to do this. Okay? So what's going to happen there is I'm going to divide 8 by 34. Okay, 8 divided by 34. And I'm going to figure out what that is a fraction. 4 over 17. So the cosine here is 4 over 17 square root of 17. Okay? Tangent, 2 over 8. All right? Go ahead and see if you can reduce that fraction. 2 over 8 is going to be 1/4. Okay? All right? I don't care if you don't reduce this, but if there's a negative that cancels out, that's where you're only going to have the issue. Okay? Now, let's go over to cosecant. What happens here, if this is my ratio, it flips. So I got 2 square root of 17 over 2. Well, this now is easier. 2 divided by 2 is 1 square root of 17. I don't need to rationalize that because the 17's up there. This one, it was 2 square root of 17 over 8. Okay, so if I divide that, that's 1/4 square root of 17. Once again, don't have to do much there. This one was going to be 8 over 2, which is going to be 4. Okay, I don't have to do much there. So the idea when you have these radicals, 2 of them are going to be hard. The other ones you're going to flip over pretty easily. Okay, let's go on to the last 2 problems. Almost done here. If I run out of time because the class comes in, you're just going to have to do that one on your own. But here's what I would do with this. This is 6 and 8. Make sure I did that right up here. Yeah, I did that right. Okay, 6 and 8. Okay, if you do Pythagorean Theorem, what you figure out is this is 10. Okay? Okay, so that's 36 and 64. That's 100. If you take the square root of 100, that's going to be 10. Okay? Now, I'm going to go ahead and put the negatives in. Okay? All right? This is going to be my hypotenuse, opposite and adjacent. Once again, we're going off the assumption that this is my theta. Okay? So the sine is going to be negative 8 over 10. Okay, I didn't write 10 very nicely. All right? No issues there because I only have a negative. Cosine is going to be negative 6 over 10. Now here's where you have an issue. Negative 8 over negative 6. You can either write that as 8 over 6 or 4 over 3 because negative 8 divided by negative 6, okay, as you can see, is a positive number. So you really have to watch that, okay? There's a shortcut here. That means the cotangent's got to be 6 over 8 or 3 over 4, okay? Same thing with all these. They all flip over. So negative 10 over 8, okay, negative 10 over 6, okay? All right. Doesn't matter where the negative, as long as there's a negative in there, it doesn't matter whether it's the top or the bottom, okay? All right, last one. This is 10 and 5, okay? So if I do Pythagorean Theorem to find my hypotenuse squared, that's going to be 5 squared plus 10 squared equals my hypotenuse squared. So it's 25 plus 100, all right, which is 125, okay? Now when I take the square root of that, that's going to be a nasty decimal. So square root of 125, nasty decimal, so I got to break that down, all right? So basically it's 5 and 25, 5 and 5, can't use these, the pair. So what that's going to be is 5 square root of 5, okay? Now, I'm going to go ahead and put the negative in right there, okay? Now, for sine, all right, this is the hypotenuse, this is the opposite, this is the adjacent. The same thing that happened from before. So that's going to be 5, okay, over 5 square root of 5. So what I'm going to do is multiply by square root of 5, okay? So that's 5 square root of 5. I'm going to use my calculator to figure out the bottom. And what's nice is you only have to do that once, okay? So I've got 5 square root of 5 times square root of 5. Okay, so I got 25. So if I divide these two numbers out front, the 5 divided by 25, I get a fraction of 1/5. Okay, so sine is going to be 1/5 square root of 5. Okay, for cosine, it's the same thing. Negative 10 over 5 square root of 5. All right, I already know what that's going to multiply. It's going to be negative 10 square root of 5 over 25. Okay, and I'm going to do negative 10 divided by 25, and that's going to be negative 2/5. Okay, so the cosine one is negative 2/5 square root of 5. All right, tangent, 5 over negative 10, if you want to write it like that, or negative 1/2, that would be okay. The easy flip for this is negative 10 over 5, or, all right, negative 2. Okay, either way, that's fine. Now on this one, okay, what you're going to do is you can start here, you start here, flip that, so that's going to be 5 square root of 5 over 5 to start. If I divide that